chats on. Where are they? Your live seems to be on a different topic than selected. What? Dude, what did they do to this? I'm not... Oh, learning. Cool. They put all these updates out over the weekend. Okay, then let's get this live. There we go. Okay, chat's working. Chat is working on TikTok. Let's see what we got. Not weather in Philly. Okay. Actualofficehours.com. I think Equity submitted 3 questions. Wow, Equity.
Oh, yeah.
Rapid fire. Let's see what we got. The position vector to the midpoint of the segment containing the 2 points. Ooh, this is fascinating. Vectors are dope. I like vectors.
That's dope.
Okay. Find the position vector to the midpoint of the segment containing the 2 points. Oh, okay. Interesting they say the position vector. Are they just asking for, like, what the midpoint is? I believe so, right? Like, if I were to think about this in 3-dimensional space. Yeah, from the origin, right? Yeah, exactly. Yeah, that's what I think so as well, right? So if we were to graph this in, like, magical 3D land, right? And let's call this, like, X, Y, and Z. Right, 5, 8, 3. This would be, like, somewhere over here. Or I guess it would be a little bit more up in Y. There we go. Okay, cool. And then, like, yeah, right? And then 11, 20, and 9. Well, that's really far out. Wow. That's, like, way over here. Way over here, way over here. Okay, so then this right here is, like, 11, 29. And then there's a segment. So it's not a ray. It's not a line. It just connects these 2 points. And then there's got to be, like, some midpoint here. And then I assume, yeah, what Jeff is saying, that the vector is from the origin. So they're talking about, like, this. I guess I would have liked to have made it whatever, something like that. Yeah. Okay. Because all these points, so this is a point, right? If you were to write this as a vector, as like 5, 8, 3, that's the vector that points from the origin to that point. So I think if we just get the midpoint and then just put brackets around it, now suddenly it's a vector that goes from the origin to the midpoint. So, midpoint formula. After this, do some examples in 6 to 7 dimensions. No. Dude, 6, 7 is dead, dude. Can't. We killed it because we millennials and older boomer and Gen X people started using it. That's effectively how we kill things. We start using it. Now it's like no longer cool. It's like what happened to Facebook. Everybody's like grandma and grandpa started getting on Facebook, and then we're just like, we need to go to Instagram. We need to go somewhere else. I used to post the most unhinged shit on Facebook, looking back. But now, like, my Facebook is like an extension of my LinkedIn almost. It's just super clean. Okay. So, midpoint formula is just this. It's just like, what? X1 plus X2 over 2. I was thinking about this and immediately started thinking about a Bridgeport mill. Yeah. I worked on a Bridgeport mill in undergrad. I took a couple... Well, I didn't take any milling classes, but I definitely had to, like, get things milled. And then whenever I would go to the machine shop to get things milled, I would kind of ask them, like, hey, man, can you just, like, teach me how you guys do this anyways? Very useful thing. I wish I learned how to weld. That's my one regret from grad school, is that I never got someone to just teach me how to weld. I feel like I could have acquired that knowledge pretty easily if I just spoken up a little bit more about it. Yes, it was. You used to have a college email in order to have Facebook. That's what people don't realize. It used to be you could only have Facebook if you were in college. It was pretty cool. Yeah. It's not too late. Yeah. it's just like it would cost me money now to learn how to weld. And I could have, I mean, dude, in college, I was just like bored. You know, instead of like playing beer pong one of the nights, I could have like learned how to weld. Or grad school, sorry. Yeah, okay, there we go. And then this is 8 plus 20. Does solving this get you girls? Solving this will get you closer to a degree, which has been shown to correlate directly with higher income. And higher income definitely correlates with getting girls. So yes, if you want your answer, not directly, but indirectly, yes, correct. All right, so 5 plus 11 is 16. 16 over 2 is 8. And this is 28 over 2, 14. Yeah, lock in, dude. Usam says, I don't have a good grade in grade 11 university physics. Should I take grade 12 physics next year? Yeah. I mean, why do you not have a good grade in physics is probably my first question. Is it because you just didn't turn in your homework, or you had a shitty teacher, or are there like things that you just don't understand? It helps to be a decent person. Agreed, Obi. It definitely does. Definitely does. But I would say the initial interest, money definitely helps. Keeping them, you have to be a good person, for sure. Half mustache James. Okay. I should go to a community college and take it. That would be cool. Anyways, all right, equity. I think this is it. And I'm not going to do these because it's just the same fucking shit. According to the answer key, it's not. Yo, what? Okay, well, what's the answer key then, equity? Tell me, bro. You got to... What? What's the answer key say? So maybe it's from the first to the midpoint? Yeah, it could be. Hello from Malaysia. What's up, Jeff from Malaysia? Welcome. I'm gonna go to Japan next month. Not next year, next month. Maybe in 2 months. What's up, Raven? I could teach them the cross product, Jade. That's a little bit much. Sorry. You said you posted it? Alright. Okay. Wait. This is for question 21. Where's for question 20? You gave me the one for 21. But okay, I can see. Oh, you're back. What's up, Star Prod? We are back. We are back. Yes, I apologize. I was in Seattle for a bit. Jeff is right, by the way. So according to your answer key, so they're calculating the midpoint for this one, which I agree, right? 6 plus 22 is 28 divided by 2, 14, whatever. Yeah, this is the midpoint of these. And then this vector is from the first point to the midpoint. Or wait, is it? Wait, no, it's not. Wait, what the fuck? Excuse me? No. Wait, what? No, it is. It is. Sorry. Yeah. Yeah, this to this, right? Yeah, is 8. 9 to 5 is minus 4. 4 to 8 is 4. It is. Yes, okay. Okay, good. Okay, so this right here is the midpoint. All right, well, here, let's just... Yeah. It's a badly worded question, Equity, to be honest. Because they didn't mention anything. You could also subtract the two vectors and divide by 2. That's another way to do it, yep. Yeah, well, you can subtract the two vectors and divide by 2. Yeah, that's actually another cool way to do it. So this, for instance, this is the this is the midpoint, and then they want the vector. Yeah, this is where this is weird. The position vector to the midpoint of the segment. I guess this means like from the first point. Raccoon says the midpoint of 3 and 9 is 11. Am I missing something? Where are you seeing the 3 and 9? Oh, yeah. No, I'm being dumb. Sorry. Yeah. I don't know why I put 11 here. This is 6. Yeah. Yeah, 3 plus 9 is 12. 12 over 2 is 6, not 11. Disqualified. Thank you, Green Raccoon. Okay, this is the midpoint. And then so from first point to midpoint, that vector, is going to be, it's like mid x minus first x, comma, like mid y minus first y, comma, mid z minus first z. So in this case, it would be 8 minus 5, so that would be 3. And then it would be 14 minus 8, which is 6. And then it would be 6 minus 3, which is 3. Cool. There you go. That is it. Now, the other way to do it, yeah, which is clever, what Psycode says, you could also figure out the vector between these two things and then just divide it by 2. Are 3D vectors a big difference from 2D? No, it's just, you're just adding another dimension. A lot of the math is the same. You just have to add like another thing you got to keep track of. So for instance, in magnitude of 2D vectors, you just do like x squared plus y squared, right? This is like the magnitude of a vector that has only 2 dimensions. When you add a third dimension, you just have to put another one in there. No, you could put it in another dimension like time or something. Yeah. A lot of the math is the same. It's just you have to add more things to calculate. So yeah, another way to do this would be to calculate what this vector is. Which here, let's use a new color. Let's use this. So that one right there would be 11 minus 5, comma 20 minus 8, comma 9 minus 3. It's like 3D triangles. It is. Oh, yeah! That's exactly correct. Okay. So this would be 6, comma 12, comma 6. But then you want to the midpoint, so you want half of this vector, right? So then you just do this divided by 2, and that would get you 3, comma 6, comma 3, which is the same answer we got here. Cool. So, yeah, poorly worded question, but I think I understand how it works. I hope that makes sense to you. Equity, yeah. Great.
That's dope.
2 ways to do it.
Well done. Well done.
And then, one second, let me fix this. Beam settings. Okay. 3D vectors. 2x cubed minus 6x. Wait. What are you saying to me, Anthony, dude? Wait, what? Is that a question you're asking? Okay, let's drop your screenshot in. Equity. Oh, it's an inequality. Oh, I see. You want me to just solve that inequality? Here, equity. I'll do your next one after this. Let me just do this real quick. 2x cubed minus 6x squared is greater than or equal to 18x minus 54. Well, that's cool. I think usually we solve this like equal to 0, and then we find out what the critical points are, and then we figure out the behavior in between them. I think that's the way we usually do this. So I would move everything over. So I would say 2x cubed minus 6x squared minus 18x plus 54 is greater than or equal to 0. And then this you want to try to factor, which I already see some trends here. You see how this is like 3 times this, and this is like 3 times this? When this happens, you can usually like pair things off, is what you can do. So for instance, I could take these two, and let's see what I can factor out of them. I can factor 2x squared out. And so this would become, so 2x squared times what gets me 2x cubed? That would be x. Then 2x squared times what gets me 6x squared? Well, that's minus 3. And then from this, I would factor out an 18. And I think I want to factor out a minus 18. I'll show you why. Yeah, you could divide. Oh, you could all. Yes, Green Raccoon. You could also divide everything by 2. Yeah, that's also valid. I'm gonna factor minus 18 out. So minus 18 times, and then this would become just x, right? Because minus 18 times x would get you minus 18x, and then this would be minus 3 because minus 18 times minus 3 would get you positive 54. Cool. And then this is greater than or equal to 0. And then yes, Psychode's totally correct. Let's just factor a 2 out, right? I can factor a 2 out like just right off the start. So divide by 2, divide by 2, divide by 2. 0 divided by 2 is just 0. So last thing you get is so x squared, x minus 3 minus 9, x minus 3 greater than or equal to 0. Now you can factor, because these two things will become x squared minus 9. And then this becomes times x minus 3. And then this is all greater than or equal to 0. Wow, so wait, this is like... Okay, so from this is degenerates. You get 2 solutions, right? So this gets you x is equal to plus or minus 3, and then this just gets you x is equal to 3. So, no new information here. I guess positive 3 is order 2 or something. Okay, so x equals 3 or negative 3. So then the next thing you want to do is you're going to create like your little number line here, and these are what I call like kind of interesting points, critical points, I think is sometimes what they call them. So I'm going to put minus 3, which is always exactly. Yep. Yeah. And then I have 3 here. And then what you want to do is you want to test like what happens. So because this is greater than or equal to, that means I can put solid circles around the minus 3 and the plus 3. Gold special minus dude, this is not a 4. No, this is not a 4. Oh God. No, this is not a 4, dude. What? This is a 4. I cross my 4s. Ugh, the gold special. My 9s look like 4s. There you go. Does that make okay. Okay. So, because this is not on my watch, Dr. Gold. Because this is greater than or equal to, we are going to include the solutions at negative 3 and positive 3, okay? Now what I want to do is I want to pick some numbers in these different regions, like region here, region here, region here, and then test them with my statement to see whether it's true or not. So the easiest one to test here is just x is equal to 0, because that's in between minus 3 and 3. So if we plug 0 in, right? Note that I have x minus 3 squared, which is always non-negative. Yes, I guess this does factor to x plus 3, x minus 3. But if you just plug 0 in, right? If this is 0, then you get negative 9 times negative 3. And negative 9 times negative 3 is positive 27. Again, I don't really care what the number is. I just care whether it's positive or negative. A negative times a negative equals a positive. And a positive is greater than 0. So in this case, this region gets a check. So it definitely does work, at least from here to here. And put like kind of a little salt line. Don't worry about the test points. Oh, okay. You have a graphing calc. Well, you want to be able to do this, Anthony, like fast. You don't want to have to be like plugging this shit in your calculator all the time. Wouldn't minus 3 not be a valid solution in this case? Why do we say that? I think minus 3 would be. If you plug minus 3 into here, you get minus 3 squared, which is positive 9, and 9 minus 9 is 0, right, piggies? And then 0 times, I don't care what this is. It's going to go to 0, right? 0 times whatever is 0, as long as it's not infinity. So I think minus 3 is valid. I could see why you might think that, because you would say, oh, this is 0 times -6. Oinkiest piggies. But 0 times -6 is still 0. So then you can do another test point. So we could try something greater than 3. I like 5. Let's do 5. If you plug 5 in, this becomes 25 minus 9. These are propulsion. 25 minus 9 is 16, so this is positive. This is positive. Oh, wow. Positive times a positive is also greater than 0. Okay, so this is also good. Crazy. Wow. So this is okay as well. Okay. Okay, so then let's go less than, maybe. Let's do -5. Okay, if I do -5, this is going to be positive, but this will be negative, right? Because -5 minus 3 is -8. Positive times the negative is negative, so now this doesn't work.
That's dope.
Okay, so this region is a no-no.
No.
Okay, so based on these two regions being okay, so it's actually funny, the 3 doesn't really count. So at the end of the day, we say that, I'm pretty sure we say our answer is -3 inclusive up to positive infinity. I think. We can check that. Yeah, you don't count it because it's a double root. What's up, Shaq?
Yo, what's good, Gold?
What's up, dude? I'm back.
How you doing, man?
I'm good. Are you freezing up in where are you, in Boston, Massachusetts? You're somewhere it's cold, I remember.
No, I'm in New York. I'm in the Big
That's
Apple.
also cold. What? It's really cold.
Blizzard.
Tis a blizzard. Are people just... I saw people were like
had to
skiing
move,
in the
like-
streets and stuff.
Yeah, I had to move like 3 feet of snow twice.
Wow.
Yesterday and today.
You know what you should do? You should start hustling and start like, I don't know, shoveling snow for money.
No, there were so many kids doing that.
Oh,
I was
okay.
Like, oh my
Bless
God,
them.
bro, it's too mainstream.
dude.
It's not niche anymore.
It's too niche. Nice. Oh wow, look at this graph. Oh, this is cool. Ladies and gentlemen, look at this graph. It's actually really cool. So yeah, this is positive, right? For greater than -3. Yeah. It looks like it would maybe bounce here at +3, but because that's a repeated root, this is actually a really cool thing about graphing polynomials. The order of this root is even, which means it doesn't cross the x-axis. It bounces off of it. This is where it goes bounce. And then it heads right back up. So, yeah, very cool. It is a double root, but it's still greater. Okay, cool. All right. So, yeah, so there's your solution. Anthony, does that make sense to you? Yeah? Just in general, right? If you're given a weird inequality polynomial thing, set it as a single polynomial with something with 0. And then go find some critical points and test. You have another question. That's cool. I will add that to our list. Let me do equities first. But here, I'll put it in here for you real quick. What was it? Sine of x equals 21 over 29. And then pi over 2 less than x less than pi. And then state the exact value for 2x. You mean sine of 2x? Or they want to know, like, 2x is equal to what? Well, that's kind of weird, actually. Wait, what? Is that a special triangle, the 21 29s? Is that a 3 4 5? Yes, hello. Did you ask a question? Oh, they want the sine of 2x. Okay. I will put that in the queue of things to do. In general, it's nice. Use the actual office hours queue. But okay, yeah, hello. If you want me to solve your question, best way for me to help you guys out, this is the website. It's called actualofficehours.com. Also, so since we did your question here, Anthony, what I'm gonna do is I'm gonna save the screenshot of what we did here. So you don't have to screenshot it yourself. So here, this is Anthony. And then what happens is we're going to go put that into our Discord here. So in our Discord, I'll create a new little thing for you. I'll say, Anthony, Free of cost. Yeah, everything's free. Yeah, everything's totally free. Yeah, this is we help people out for free. No strings attached. There you go. So Anthony, you will see the screenshot to your question is right here. So yeah, if you want to go figure out where that is, the website here, actualofficehours.com, is the best place to go click join our Discord. Get all the help. What is the meaning? You know that means Jeff? What means Jeff? Oh no, oh no. Oh, does Jeff lose more years? Is Jeff has lost 1996 as well? And while you're there on the website, submitting your screenshots for us to help you, also check out the streaming schedule. This is a big, awesome calendar. Look at all the things that are happening. This is so dope. This makes me so happy every time people start putting more things on the calendar. But yes, oh, awesome. We got Math Pond on the calendar now. Great. Yeah, Math Pond was doing like some, I want to say linear algebra lessons. But yeah, these are all the awesome math and science streams that are happening this week. So, I mean, I'm just one of these people. So go check out all the other people there. They're awesome. They're great. Everything yellow. I did do that on purpose. All right, let me do Equity's question. And then, Anthony, I'll do the other one you have there. So let's see. Find the orthogonal vector to this. Great. Love that. Yeah, I think the 2129 is a special vector. Okay. Find a vector orthogonal to that. Okay. An orthogonal vector means that the dot product would be 0, right? Yeah. Exactly. Okay, good. So if A is perpendicular orthogonal to B, then A dot B is equal to 0. Because dot products measure like how much of this vector is pointing in the same direction as this vector. And if you have two things that are perpendicular to each other, then none of this points in the same direction as this. So I just need like something. Here, we can call this like x comma y comma z. And that when I dot that with this vector, which this is 1 comma 3 halves comma minus 5 halves, I need this to equal 0. And how dot products work with vectors, yeah, it is gross, right?
Disqualified.
You do this times this plus this times this plus this times this. Yeah, you have so many things you can choose from. Literally you need any combination such that, for instance, x times 1 plus 3 halves times y minus 5 halves times z has to equal 0. So, I mean, right off the bat, I could make, for instance, I don't know, whatever. Let's make x equal to 1. Let's make this equal to negative 3 halves, right? Because negative 3 halves, or negative 2/3, sorry. Because negative 2/3 times 3 halves would get me negative 1. And then I could just make this 0. Okay. So yeah, this is something. So I would say 1 negative 2/3 comma 0, right? Why scalar multiple? What's up? It wants orthogonal. So this is not a scalar multiple of this. I don't think it is it? We just want some vector x, y, z that if I dot it with something else. Oh, what? Oh, Jeff said. Okay, my bad.
Surprise, motherfucker.
Sorry, the chat goes off a lot. I need to keep up with all that's going on in chat. No scalar multiples of each other. Right. Okay. I think I see what he's saying. Wait, could you have something be a scalar multiple of it and the dot product be 0 though? I don't think so. Is that possible? No. It would be negative, right? If something is a scalar multiple of something else, the dot product would be non-zero. You could have lost another year there.
Disqualified.
Okay, there you go. Yes. Oh, if a dot b equals 0, then a dot kb is equal to 0. Okay, I see what you're saying. So a scalar multiple of this. Yes, okay, sure. So this would work. And you could say also, if you multiply the whole thing by 3, 3 comma negative 2 comma 0 would also work. Yeah. I agree with that. Yeah, because if you just add another scalar multiple here into this whole thing, if these two things dot product to 0, multiplying by k is also still going to be equal to 0. Is work done on a scalar product? Work is a dot product, yeah, which is called a scalar product. That is right. Those are correct, yeah. So work is equal to the integral of like f dot dx, and this is a scalar product. Yeah, okay. Find the unit vector orthogonal to these two things. Okay, so this is cool. So if you want something that's orthogonal to two vectors, you find the cross product of those two vectors. So this is number 4. So number 5, you have two vectors, which is like 1 comma 2. And wait, what? Is it the wait, that's the same vector, no? Wait, what? Excuse me? Wait, what? Find a unit vector orthogonal to this? Am I having a stroke, or is this the same thing? Okay, cool. Did you upload in the live queue? I don't see yours. I only see 3 things in the queue right now. Hello, 24K. Or are you Dr. Gold fanboy? Is this you? I don't think so. This is the queue so far. Okay, so this is actually really dumb. But okay, something orthogonal to this, and then they want the so this is where the scalar multiple comes in. So I need, this is so silly, x comma y. Do you write unit vectors do you write unit vectors with ijk or in component form? It's kind of the same thing. So yeah, I mean, this in ijk form would just be 3i minus 2j plus 0k. These are both equivalent. Because I vector is equal to like 1 comma 0 comma 0, which is also like x hat. It's kind of silly how they write. I mean, I also, you could write it this way. You could say 3x hat minus 2y hat plus 0z hat. I don't know. The hat usually signifies unit. If you use the ijk form, you can do quaternion multiplication. No. What? Why? We don't need to deal with quaternions right now. Okay, so here. So for this one, right? I need something where 1 times x plus 2 times y is equal to 0. Something for that would be, for instance, negative 2 comma 1, right? Because negative 2 times 1 would be negative 2 plus 2 times 1, which is 2, which is equal to 0. Yeah, negative 2 plus 2 is 0, yeah. This is not a unit vector, though. Okay, so if we want to turn this into a unit vector, all we have to do is just divide by its magnitude. So let's say, for instance, this is vector A. If I want a hat, this is equal to a vector divided by the magnitude of A. That's how we write it. So this would be negative 2 comma 1 divided by the magnitude of this, and then the magnitude of this is just equal to the square root of the component squared, but like summed. It's like negative 2 squared plus 1 squared. So that equals the square root of 4 plus 1 squared of 5. Yes, you could also rotate. Yeah, you can also rotate. That's another way to get it for to be orthogonal. That is true. That's a little bit more complicated. We could do like a transformation matrix, I guess, right? Okay, cool. So then this gets you, I think this is the appropriate way to write it. Well, If they want it in component form, you would say like -2 over the square root of 5 I plus 1 over square root of 5 J. But then, like, people don't like this. They don't like the square root of 5 on the bottom. So they would say this is -2 square root of 5 over 5 I vector plus 5 square root of 5 over 5 J vector. There you go. That's also, like, technically correct. The way I would write this, I would just say this is 1 over the square root of 5, and then I would just say, like, -2 comma 1. This is like the real application of when you would do it. This is just silly. It's a perfectly reasonable answer, and they can live with it. Yeah. Okay, cool. Nice. Okay, great. Another cool one, Equity. Appreciate it. Yeah, Corb, what's up, dude? Oh, swap components and negate one. Oh, that's fun. And actually, that's literally what we did. Right? We swapped these, right? And then we made one negative. I don't think that's the answer. Well, there are many answers. Well, show me what the answer is. I'm curious. I do need to hydrate. Thank you, Shaq. Why are we going to Discord? What? You look famished. I see yours now. Hello. Yep, I see yours. Why did you swap them? So, yeah. So, this is actually kind of a cool thing. So, since this is in 2 dimensions, right, Equity? Can you show me how to simplify radicals that are being divided with a negative exponent? Yeah. Can you post an example of one? Like a screenshot of one? John Sycaris? If you post it to that website, actualofficehours.com, just send me a screenshot of what, like, is one that you need help with, or looks like one, and I'll explain why it works. So this was 1, 2, right? So 1, 2 is 1 unit here, 2 units here. So that was this. So this is 1, 2. And Psycode said that, oh, okay. Well, in order for something to be orthogonal to this, perpendicular to this, right? It needs to be 90 degrees to it. So what you could do is you could take this vector and you could rotate it 90 degrees. Now you can rotate it 90 degrees this way, or you could even rotate it 90 degrees this way. The rule you learn for, okay, sweet, John. Yeah. We're on all the other platforms, John, by the way, too. If you go to the website, actualofficehours.com, you can see we're on YouTube. Twitch is actually the better place to watch it because it's horizontal, not vertical. We just do vertical on TikTok because that's how they like things. It's in 3D, by the way. Oh, well, I don't think it is. Because this is a 2-dimensional vector. Yeah. Also, I think your teacher fucked up.
You done messed up, Aaron!
Because they put the same vector twice. If those were 2 separate vectors, then I agree. It could be in 3 dimensions. Okay. It says K is 0. Yeah, but it's the same vector. I'm not crazy, right? Yeah, if K is 0, we can treat it as 2D. Yeah. Also, yeah, this is literally the same vector. Right, and then this is, yeah. You can do the cross product normalize. But what's the cross product of 2 vectors that are the same? Right? What? This is another way to do it, is if it's in 2 dimensions and you want to just rotate something 90 degrees. Yeah, it's degenerate. Yeah, exactly. Exactly. I agree with that too. Anyways, so to rotate 90 degrees, Yeah, and I wanted to do the cross product. That was the first way I wanted to do it, but then I saw the teacher literally put the same fucking vector. No. And I'm like, oh, I can't really do this. But where's the fun little table of them? One on the table. There's a cool little table of them. I don't want the actual matrix. Nope. 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 Where is it? There's always like a little fun one that says how to do it for like, yeah. Oh, there you go. Well, this is what I wanted. There you go. This is the other little tidbit that works. What's up, Vernon? So if you want to rotate something by 90 degrees in the clockwise direction, all you do is you flip the X and Y components. So instead of 1, 2, this would become 2, 1. And then you make this one negative. So that's why it's 2, -1. What about 360 degrees? Oh. Okay, Jeff. Jeff's just trying to get yours back at this point. Yeah. And that's literally what we did here, right? We got -2, 1. So actually what we did... Oh, because we did it counterclockwise. Counterclockwise, you make this one negative. Not the other one. I posted this answer in office hours, so would you have to solve this question like the last guess and check? The answer both questions. Zero vector is not a vector. It's not a... Yeah, your teacher's drunk, dude. What? Sorry, what's going on here? Chat is spicy today. I do like, yeah, chat's popping off today. I'm happy with it. I'm here for it, dude. Can you explain the Laplace second shift theorem? Ooh, if you give me an example one, I can try to do it. The shifts are actually tricky. So here, yeah, your teacher tried to do this, which is dumb. No. Like, don't do this. Don't.
Oh,
what?
no. Oh, no.
Yeah, the cross product is gonna get you nothing. But this is correct. Any vector where u dot v is equal to 0. I agree with this. And that's what we did. It's not guess and check. It's just, what do I need to put for x and for y so that this equals 0? And this is like the most obvious one to me. It could have been -4, 2. You could do whatever. Just, you know, work smarter, not harder type shit. But the other way is that if it is in 2 dimensions, you can just apply a rotation of 90 degrees in either the clockwise or counterclockwise direction, and that will get you something that's orthogonal as well. Okay, cool. All right, I'm done with this. Moving forward. All right, equita. Good. Yeah, you're welcome, dude. You have another one that I might do. Let me just get some more time on people. Hello says hello. Okay, 1 sec. Let's see. You said yours is really easy? Oh, yeah, okay, here. Let me do hellos real quick, because hello's new. And then I will do this one, Dr. Gold fanboy. This is polarized beams. More optics. No. It's giving me more optics. I don't like optics. Here, hello. I'll do yours though, because also your name has 24 carats in it. Do some optics while I'm gone, so I won't miss anything. All right, Jeff. All right, let's see this one real quick. Square root of 5 minus x is equal to 5 minus x squared. Oh. My gut instinct is I don't like square roots. No. So, I'm gonna square both sides real quick. So that's 5 minus x is equal to 5 minus x squared. Squared? Yeah. So that's 5 minus x is equal to 25 minus, or let's say plus x to the 4th. And then we're going to say minus 10x squared. That comes from just expanding this, right? So a minus b squared is equal to a squared plus b squared minus 2ab. And that's where we got this from. Okay. So let's see what we got. Let's move everything over. So I got x to the 4th minus 10x squared plus x. What's that? 25 minus 5 plus 20. And then this is equal to 0, right? That's a mess. This doesn't factor very nicely, does it? I don't feel like it does. Because 1 doesn't work. Maybe 2 works? No. So unlike Anthony's question, which was nice, Anthony gave me this, and then this was very easy. When you have things that are 4 terms in terms of polynomials, it's nice to try to see if you can like group them. And they have common relationships. These ones don't.
Disqualified.
Furthermore, I'm just looking at this. This is restricted. Right? This has to be positive. I actually don't think there's a solution for this. Yeah, I don't think there is a solution. So first of all, this must be positive, right? So this, you have that x squared has to be less than or equal to 5. Right? So then x has to be between the square root of 5. Yeah? Or, sorry, what did I write here? Kind of like this, yeah? I don't know that it's hard. Yeah, I don't see how to solve it. It's just fucking annoying. It's not hard. It's just dumb.
I just said just shut up and let me.
What's up, Black Pill Ascension? That's an interesting name. Don't take the black pill, please. It just proves that 0 equals 0. Yeah. Okay. You could, if you wanted to put this in the Desmos. X to the 4th. What was it? X to the 4th? I don't think there's an analytic way to solve this. Sorry, hello. I'm gonna do it. Plus x plus 20. Yeah, these are weird numbers. Like what? What? Excuse me? Also, yeah, what's y is equal to the square root of 5? Or sorry, x equals the square root of 5. Because we had rules, right? Yeah. The incel is back, I guess, watching Actual Education. What's up, dude? Yeah, so this is actually a really cool thing. So remember from our earlier requirement here, right? Where we said that this had to be positive, right? So if this has to be positive, your solutions for x, because this is a square root, they have to be between negative square root of 5 and positive square root of 5. So already that gets rid of this negative 2.79 solution and this 2. Not an incel if I'm Chad, that's true. But I feel like the black pill is like disregarding all like Chadness or something. I forget. I don't know. All right, 2.56. So it has to be. It's these two weird ones. It's negative 1.56 and 1.79. Yeah. This is not a quadratic. A quadratic is something of the form like x squared plus blah 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 x plus blah blah blah, or plus blah 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 x to the 0 is equal to 0. It's TikTok brain rot. Yeah, polynomial division would maybe work, but this is there's no rational things here, right? I don't see anything nice that this could be. You won't hint. I don't know what. It's tricky. Okay, well, let me help out other people because there's a lot of other questions. If you want to give me like a hint on like how to do something, it's just like tricky. No teacher's gonna ask this on a test question. It's just not gonna happen. It's just annoying. Okay, let me help out Anthony with this one. It's okay. Don't be sorry. Yeah, it's fine. It's not your fault. Okay, sine of x is equal to 21 over 29. What is the sine of 2x? All right. So, I think the thing to realize is that this is a special triangle, right? Because if I wanted to get x, actually, I think I know what I want to do. There's an identity for sine of 2x. What is it? Because I want to do things in terms of just sine of x. Yeah, this is what I want. Okay, so sine of 2x is... I hope these are right. Sometimes when I go to find equations on Google Images, they use the wrong things. Like someone posts the wrong equation in the image. It's super annoying. Okay, so sine of 2x is the same thing as this. So sine of 2x is also equal to 2 times the sine of x times the cosine of x. Well, I already know what the sine of x is, right? Sine of x is equal to 21 over 29. No, you're not disturbing me. It's okay. This is 21 over 29. But now I need the cosine of it. Okay. So this is where, again, it would be nice to know what x is by taking, for instance, so if sine of x is equal to 21 over 29, then sine negative 1 of this is equal to sine negative 1 of this. This is how like inverse. I literally just did a video on this on TikTok. I made a video on this. Okay, so this would go away, and you would just get x is equal to the sine inverse of 21 over 29. But I want the cosine of that, right? So yeah, so if I wanted the cosine of that, okay, this is effectively what I'm doing. I'm figuring out what is the cosine of inverse sine of a number. Now, I could use a calculator, get a number here, and then take the cosine of it, but that's dirty and unnecessary. Because the cooler way to do this is to realize that cosine is acting on an angle. And the angle happens to be a triangle where the sine of that angle is 21 over 29. So from this, I can just draw a triangle where I know, well, actually, the triangle should be the other way, shouldn't it? Yeah, my bad. Yes, yeah, Alistair, that is the other way to do it. That is the other way. I know that way works as well. And it uses the same thing, but I think this is kind of the cooler way to do it. So, if this is, let's say this is some angle theta, the sine of that angle needs to be 21 over 29, right? Opposite of hypotenuse. Okay. But I want the cosine of that angle theta, which is a triangle with an opposite over hypotenuse of 20 over 29. So, cosine is the adjacent over the hypotenuse. And because this is a right triangle, I can figure out the adjacent. I could use the Pythagorean theorem. Or this is a special triangle. I don't know if I know this one. I know 3, 4, 5, 5, 12, 13. The other ones. So, special right triangle. Or they're called Pythagorean triples. There we go. Bingo. This is them.
Bing bong.
So the Pythagorean triples, right, so 3, 4, 5, 6, 8, 10. which is just a multiple of 3, 4, 5. 5, 12, 13. Where's the 29? Here it is. 20, 21, 29. That's what I want. So this, I know, is 20. And then, so the cosine of that triangle is then 20 over 29. Oh, one sec. TikTok doesn't think I'm real. Okay. So this part right here becomes 20 over 29. So then sine of 2x is equal to... Yeah, no, I know. People... Yeah, my 9s look like 4s. All right, I'll fix. I do need to get better at that. People are getting confused. You're not the first one. There we go. No, it's okay. I don't know at what point in my life that my 4s started looking like 9s, but apparently they do now. Okay, so it's just 2 times 21 times 20 over 29 squared. And so what is that? 8,400? Is that 8,400? No, 840, right? Yeah, 840. And I don't know what 29 squared is. What is 29 squared? Something less than 900. 841. Oh, wow. That's actually really cool. That's what happens when you don't take care of your 9s. They decays into 4s and emit gamma rays.
No.
See, I think my 4s are very distinct from my 9s, though. Anyways, okay. There you go. Nice. Cool. Good job, Anthony. Great question. That was a fun one. Nice. All right. Let me drag this into our screen, into our Anthony 2. Call it math. Nice. All right, Anthony. I put the screenshot here in our Discord, so make sure to go join if you want to see every question we do during the stream. Will get posted in here at some point. So, for instance, this is Anthony's question and his solution. Did I give you points for this equity? I should give you points. Did I already give you points equity? I think I did at some point, no? I did. Okay, good. All right. Let's see. What else we got? 23 viewers. Why? What's up, chat? That's a lot. Everyone's here for Monday math. Mondays are for the maths. All right, let's see. Determine which octants in which the conditions are so satisfied. Wow, this is fun. Okay. I didn't know that. Sorry, what are the labels for the octants in 3D? I know what they are in 2D. Right? I know this is like 1, 2, 3, 4. How do you label them in 3D? Or these are the quadrants, right? These are, because there's 4 quadrants. And I guess these are like octants. You use binary 000 to 111. Okay. Because I guess there are 8, yeah. Let me see if there's a way they do it. Peace. Peace, hello. Okay. This is odd, but I think I see it. They also call it like plus, plus, minus, plus, minus, plus. Oh, okay, okay. I can get behind this. Yeah, come on by. Yeah. Again, if you're watching, the website actualofficehours.com, where people are submitting their questions. If you click on the streaming schedule here, you'll also see all the times that we stream and all the times all of our other awesome friends stream. I shouted out Obi. Let me shout out Eric as well. He's another good one. We like Eric. Go check out Eric as well. Yeah, same thing works as binary. Okay, so let's see. So I think these are the octants, right? So it looks like they do the same 1, 2, 3, 4 for the top, but then it's 5, 6, 7, 8 for the z is less than 0, right? I think that's the difference here. Yes, Joe, I can do statistics. I love statistics. Okay. Okay, so when x is greater than 0, y is greater than 0, and z is less than 0. Ooh, that's cool. So I think that's just quadrant 5 then, right? Because this would be the quadrant where x and y are greater than 0, and z is also greater than 0. But if z is less than 0, that's the one directly below it. So that's going to be quadrant 5. Or as SciCode says, plus, plus, minus. That's another way to write it. Yeah, that's another cool way to think about it. Okay, where x, y multiplied to each other is less than 0. Okay, so that's where either x is positive and y is negative, or y is positive and x is negative. So that's quadrants 2 and 4, right? But then also the ones below it. So 2, 4, 6, 8. So 2, 4, 6. When will we stream again? Tomorrow. We're gonna stream tomorrow. An hour later. But yeah, you can also type in !Cal, and that'll get you the link for when we stream again. Where z is greater than 0. Okay, cool. That's just quadrants 1, 2, 3, and 4. And then where yz is greater than 0. Oh, this is cool, actually. How was my trip? My trip was good. I'm glad to be back, honestly. As much as I like trips and whatever, seeing family and stuff, it really derails me, though. I had so many goals I wanted to get done last week that just didn't happen. No. I don't know. It's just when I'm on vacation or I'm with family or I'm out or I'm traveling, it's very hard for me to be productive. I kind of just default into my, I don't want to do anything. I just want to like watch TV, hang, which I think is important. It's important to like have downtime, but it really derails me when I have like all these things I'm trying to get done. I can help with linalgia. Okay, SciCode says plus, minus, plus, plus, minus, and minus, plus, minus, minus, plus. Uh-huh. Yeah, I see how it works, because plus and yeah, the binary actually does work kind of nicely. But if I wanted to do it this way, I need like, so right, y positive, z negative, or y negative, z positive. And then you're right. And then I don't care what x is. So for this one, yeah. And x equals plus minus, right? Okay. So y positive, z negative. So y positive, z negative would be quadrants 1 and 5, right? So 1, 5. Yeah, bigger than 0 just means like positive. Okay, so that's where y is positive. Oh, actually, also... Sorry. Y is positive and z is negative. Sorry, I take that back. Sorry. Y positive, z negative is 5. Right? Or... Or quadrant, what's that, 6? Yeah, quadrant 6, right? So here and here, it's y is positive, z is negative. But then if y is negative and z is positive, that's quadrants 3 and quadrant 4. Yeah. Yeah, you need both positive and negative. Yeah, so 1... Wait. 1, 2, 5, 6? Oh, you're right. I do need both positive. Sorry, I don't know why I said they were negative. Ew. Yeah, sorry. So either they're both negative. Yeah, sorry. Y is negative and Z is negative, or Y is positive, Z is positive. That's what I meant to say. Okay. I thought we were doing this one where I wanted them to be opposites again. Obviously not the case. Yep. Got you. Oh, so I was right originally. Right, yeah. 1, 1, 2. And then, 7, 8, right? Yeah, 7, 8. Yep, I agree. I agree 7, 8. Yeah. Because here, Y is negative, and Z is also negative. Yeah. Okay, there we go. I think that's it. Cool. Why Nightbot never talks to me? I don't know, you Raven. I'm sorry. Oh, Nightbot is talking to you, Raven, though. Yeah. Okay. There we go. Nice. Nice. Yeah, we got that one. Nice. Okay, cool. All right. All right. Let's... Did you just assume the gender of Nightbot? We don't know what Nightbot's gender is. Okay. Oh no. Caught. Straight to jail. No, it's okay. We don't cancel anyone here. Okay, let's do it. Next one. Looks like we're gonna do polarized beams of light. Okay. A linearly polarized beam of light is incident upon a group of 3 polarizing sheets, which are arranged so that the transmission acts... Yeah, this is Malice's law, right? What fraction of the incident intensity is transferred? So anytime you go through any sort of polarizer, you lose half, right? If you have unpolarized light going through this, I think you lose half. I think, like, right off the bat, this is now SO over 2, right? And then when, yeah, this Malice's law. Okay. I don't want that. Where's just copy the image in. Yes, here we go. Right. So intensity is A naught squared cosine squared theta. Okay. So at this point, you have whatever your initial intensity was, which is going to be S naught over 2 squared, and then cosine squared of 45 degrees. And then once it goes through this, now the light is polarized at 45 degrees. So when we go to this one, you don't put in 90. It's always the angle relative to what it was last polarized at. Okay, of course, cosine of 45 squared of 2 over 2, so cosine squared would be 2 over 4, right? So for those that forgot their unit circle, cosine is 45 degrees is square root of 2 over 2. So this squared, this becomes square root of 2 squared, which is 2, and then 2 over 4 is 1/2. Okay. And then I'm guessing S naught is the amplitude of it. Well, actually, wait. Huh. Yeah. So A is amplitude, I is intensity. What is S naught, by the way? Sorry. Is that the intensity or the amplitude? I think it's the intensity, right? Yeah, right. Yeah, not sure actually. Yeah. Let's S0 polarizer intensity. Let's just see. It probably comes up somewhere. Okay, here we go. The initial intensity is S0. Okay. Okay. So, okay, so actually we don't need the amplitude. This is actually the other part of Malice's law. Yeah, and this actually makes sense, right? Because intensity is proportional to amplitude squared. So this squared, yeah, okay, that's what I kind of want, right? Okay, so this is not S naught over 2 squared. This is just S naught over 2. Okay, cool. So then, S naught over 2, going through the 45-degree angle one, is then going to cut it down by a half again. Okay, so this will be S naught over 4. And then, by symmetry, we can now see that this is going to be S naught over 8. Pretty easy, right? Yeah, because it's another 45 degrees. Okay, one sec. I'll be right back. I got a phone call. I got to pick up something from my front door that the delivery people have been waiting for a while to do. One sec. I'll be right back. Alright. The new look is crazy mogging. What? What am I mogging? Ugh, take this off. I hate signing for things. I'm like, what? Just like leave it on my front door, please. It's okay. Okay. Let's go back. Alright, light is incident from air to surface of a liquid. The angle of incidence is 53 degrees and angle of refraction is 34 degrees. What angle incidence reflected light is completely polarized? What? Incident from air to surface of a liquid. I don't actually think I know how to do this. Brewster angle? Is that where it comes from? What's the Brewster angle again? Uh-huh. Oh, okay. That's cool. I didn't know this. Brewster angle. Okay, unpolarized, partially polarized. At what angle of incidence? But then what do we do with angle of incidence and angle of refraction? I think that helps us figure out N of the liquid, right? Here, and then this is the information. Right? Because we know what N of air is, but we don't know what N of the liquid is, right? So I think how I do this is I do Snell's law to figure out N of the liquid. Because, for instance, right, I know if this is incident and has 53 degrees. Yeah, exactly. So N of the air is equal to 1, or N hair, sorry. N of the air is equal to 1, and then we need N of the liquid. And yeah, index of the refraction angle here, right, we say is 34 degrees. So this tells me from N1 sine theta 1 is equal to N2 sine theta 2, that 1 times the sine of 53 degrees is equal to N. I don't know what this N is. Let's just call it N2. And I would say this is sine of 34 degrees. Okay. So N2 is just equal to sine of 53 degrees divided by the sine of 34 degrees. And then we're told that the Brewster angle, which is the angle of incidence where you get 100% linearly polarized light, that's the tangent of theta b is equal to N2. So N2 in this case is sine of 53 degrees over sine of 34 degrees, and then divided by N1. But N1 is just 1. Index of refraction for air is just 1. Okay, cool. So tangent of theta b is equal to this. I don't think there's any fun analytic way to do this, because I need like the arctangent of this. I don't think you could do it. Where's my calculator? Calculator. I'm sure there are formulas that math nerds came up. Yeah, something for like sine A minus sine of A over sine of B is equal to something. All right, you probably could, yeah, but not calculate. There we go. All right, first let's make sure. Yep, degree mode, good. So we're gonna do sine of 53 divided by the sine of 34, and then we're gonna take the arctangent of that. And that's going to give me 55 degrees. Wow, on the money, actually. It's actually really... Wow, it's almost exact. That's actually really cool. So there you go. Theta b is equal to arctangent. Math nerds watching this. It's actually kind of cool. Yeah, right? How it came out to be basically... It's not exactly, though. Right? Do we think is there something here with how that works? It would be kind of cool. All right, nice, cool. Thank you, Dr. Gold's fanboy.
Yeah.
Cool.
Well done.
Oh, air is not actually 1. It's 1.00001. Okay, well, that makes sense then. Yeah, I mean, nothing's ever exact. We're just, like, close enough. All right, cool. Let's see. Next one was... Okay, we did yours, hello. Or I got, like, close enough to it, so... I'm going to say that I did it. Let me see what Varvar has next for us. Here, then let me download... And then, right, this one had 4 solutions. But only 2 are valid. We all doing VAR for the Huz. What is VAR? Wait, like Anavar? Night, Psychode. Appreciate you being here, dude. Yeah, thank you, Psychode. Always appreciate your insights. No, I mean melatonin. I think doing melatonin's like, it like fucks with your sleep system, honestly. You should just learn how to go to bed naturally. You know, if you start becoming dependent on melatonin, you start wrecking your sleep cycle. I'm pretty sure. I was just giving the hint what I did. I assumed under root 5 minus x as a... Wait, what? As a what? I don't know if there's an analytic way to solve this one though. Cuz melatonin is code name for Anavar? Oh, I'm learning so much these days. Wow, thanks Jeff for the sub. Was it Retta True Tide? That's the one everyone's like pinning these days, right? Retta. Y'all don't need any of that. You just need to go to the gym and like lift weights. That's what I say. I have it on my Instagram. It was my goal this year to bench 315. I do this completely 100% natural, like nothing. No, nothing. All I do is like protein and creatine. But here, I'm gonna show you. It's possible, boys. You don't need Retta. This is Dr. Golden, all his heaviness, putting up 1 rep max for 315. I think I weighed like 206 at this point. So what's that? Benching 150% my body weight? Right? Yeah. Yeah, you don't need Retta. You don't need chill. Just go to the fucking gym. Yeah, I don't think you can solve this analytically.
Disqualified.
Take Retta to ascend. Also, I can't do needles. Like, ugh, I hate needles.
You done messed up, Aaron!
Yeah, I don't think this is solvable. You know, I will post it in my Discord though. Hello, and I will see if anyone else thinks this is solvable analytically. Did you say girlfriend? I thought you meant IGF-1. Jeff says technically all are solvable. Y'all the peptides. I think it's cool that you guys are interested in like fitness at least. I think that's cool. I just think there are good ways to go about it, and then there are bad ways to go about it. And anytime something seems like a hack or like a shortcut, just generally in life, there's always a cost. So you don't want to do it. You can't replace just like hard work at the end of the day. Oh, it's an IIT. Dude, I don't do JEE problems. No. I hate JEE problems. They're terrible. Yes, I know about JEE. It's where, what is it, 2 billion people try to escape poverty. So they make the exam like ridiculously difficult. Okay, Anthony, we also did yours. I don't know if you're in the Discord, check it. I think, which one was yours, Anthony? Not this one, sorry, dog. Which one was it? Fuck, I'm very sure I did yours. Was it this one? Wait, where the fuck did we put it? Oh, this one, Anthony. Yeah, we did this one. Just bone smash? Dude, that's the worst one. Just like hit yourself. Dude, what? You realize how dumb you look? You just hit yourself in the face to cause like temporary swelling to your jawbone. It's not permanent either. Okay, for the matrix below, compute RREF. Display each non-pivot column of A as a linear combination of the pivot columns of A. Display each row of A as a linear combination of the non-linear rows of RREF. Oh, Jeff got it. What's up, Anuvan?
My man.
1 plus or minus the square root of... Is that square root of pi over 2? Yeah, wait, what? How'd you do that? Oh, you cheated, Jeff.
Bruh.
Jeff can't cheat. Okay, let's compute RREF for this. Okay, that's kind of fun. Bone smashing will always work. The thing I always like to say, because I know Clav is like coming up in whatever the sphere of influence and stuff, and people are like, look at all the girls he gets and like how he ignores them and blah blah blah. Those girls don't like him because he's attractive. They like him because he's popular. And he got popular by being ridiculous and trying to be attractive. It's not because he's attractive. It's because he's popular. Keating Garis? I don't know what that is. Okay, so I feel like when this happened, what do I want to do? I feel like I want to switch one of these. It's okay. Here, let's REF. So I'm gonna take. What is this? I'm gonna do negative R3 plus R2 implies R2. Right, so when I do that, negative this adds to this. So what do we get? Negative 1 plus 1, so this becomes 0. 0 plus 2 is 2, and negative 1 plus this is 0. Oh, very cool. Okay, cool. It's all factors, yeah. And then let's do negative R1 plus R3 goes to R3. So what do we get there? So this plus this. So negative 1 plus 1, that's going to be equal to 0. Ooh, I don't like this, though. No. Damn. Negative this plus this, that gets me negative 1. I was happy with this, actually. Well, okay, whatever. And then this plus this gets me 0. Oh, this is a linear combination of this one, no? Is that true? I guess it is actually. Wait, whoa, right? Because if I double this, but then subtract this, I do get this. Oh, that's what Galoy. This is actually cool. So, this is only going to have a rank of 2. Because now, watch what I can do here. So now I can do R3 plus R1 goes to R1. So then this is this. Very cool. This is linear algebra. Yep, this is a matrix. Well, this is a matrix. Yeah, so this was our original matrix A. And I'm trying to get into RREF form. RREF form means you want to get like 1 0 0 0 1 0 0 0 1. This is the goal. This would be a rank 3 matrix, right? But I think what ends up happening, because here's what I'm doing. I'm going from here. Because now if I do 2R3 plus R2 goes to R2. Now this will just knock this out. Okay. So then this is your final matrix. Because then you can always just divide this by negative 1. It's not hard. It's just a bunch of like little math tricks. 0 1 0, and then this is 0 0 0. Okay, cool. So this is rank 2. Rank 2 because you have only 2 non-zero rows, right? This is a 0 row. So this is a rank 2 matrix. Right? Display each non-pivot column of A as a linear combination of the pivot columns of A. Okay, so the pivot columns of A, I think these are the pivot columns, no? Right? Aren't these both pivot columns? So every non-pivot... Sorry, display each non-pivot as a pivot column. Well, cool. I mean, whatever. This one just equals this. And then display each row as a linear combination of the non-zero rows. Oh, okay. This is cool, actually. So I think this is RREF of A. And actually, wait. Correct me if I'm wrong. Pivot columns, I think, are these, right? I don't know why my TikTok chat just spammed. Okay. Okay. Display each row. So it's like, okay, can I display this as a combination of these rows? And like, yeah, cool. So in this case, row 1 is equal to, let's say, like row 1 prime plus row 2 prime, where prime represents the RREF version. Let's call this like A prime. Right? So this plus this gets me this. Row 2 equals R1 prime. Sorry, equals R1 prime plus 2R2 prime. And then, yeah, R3 just equals R1 prime. Okay, cool. I think that's it. Nice. Varvar, melatonin.
Well done! Well done!
I'm getting better at linear algebra. The matrix deletes a degree of freedom. Yeah, I mean, if it's rank 2, then that tells you that you have one variable that's free. W solution. Thanks, I need help, dude.
My man!
Yeah, I think so, Dream of Dawn, right? I feel like because the RREF is rank 2, that means that one of your variables, one of the degrees of freedom is just free.
What? Right? I still remember linear algebra. Dubs. Baby voice got engaged. So I'm gonna have a very high-pitched voice for the next 30 seconds. Nice, okay, cool. Good job, Varvar. Let's post your solution into our Discord. And they're all gonna be there. I'm fairly sure a 0 row or column in degrees. Yeah, I think so as well. I know from RREF it does for sure.
Ooh. Yo, what is this? The Coriolis force? What's going on here? This is some scary physics. Do some fluid mechanics and I'll respect you. It's only the diagram on the left. Okay, cool. So we don't actually have to worry about this. Okay, cool. In one contest at a county fair, a spring-loaded plunger launches a ball at a speed of 3 meters per second from one corner of something at a 20-degree angle. To win, you must make the ball hit a small target at the adjacent corner 2.5 meters away. At what angle should you tilt the ball launcher? This is actually kind of tricky, no? And they say this is 2.5. Because I feel like what happens is now gravity would be just acting straight down, right? You have to do like a change of coordinates here. Gravity for the kinemax equations, right, is this way. Yeah, you tried using g sine theta. Yes, it's parabolic motion with reduced gravity. But also gravity now affects the new coordinate plane, right? So let's call this, for instance, like this is y prime. Right, and this is x prime. Oh, actually, so gravity only points straight down, right? So gravity does not affect the x direction. Yeah. So there's a lower effective gravity in the y direction. Yeah, it doesn't affect x, right? Yeah. Okay. So I think it's cosine theta. Yeah, I think g prime is equal to g cosine theta. And the way to think about this is that if the angle was 0, right, cosine of 0 is just 1. And that means that g prime would just be equal to g. Oh, wait a minute. No, it is sine theta. Because if it's 0, gravity shouldn't affect it in this way as well. Where does the 20 degrees come from? The flat board is tilted up at 20 degrees. Okay, yeah, sorry. Yeah, sorry. This is 20 degrees. And then there's another angle theta you have to deal with. Got you. I think I get this now. Right? So your kinematic equations of motion, right, is x, or x prime, is just going to be equal to 0 plus... So this is going to be v naught cosine theta, right? And then there's no gravity. So then plus 1/2 at squared. So this goes away. In the y direction, yeah, v naught cosine theta times. Yep. Okay, in the y prime direction. Okay. Now gravity does have an. Let's pretend this was at 0 degrees. If this thing was flat, the motion in this direction is not affected by gravity. You did it without acceleration in x, but well, yeah, ChatGPT is gonna fuck this one up for sure. Oh wait. Oh, but the answer matches up with the textbook. G cosine theta. No. So gravity points straight down, right? Which is only going to have a component in the y hat direction, right? In the y prime direction? Is the lower left on the ground? Yeah. Think about it. If you were to place a ball, right? Let's place a ball on here, right? Gravity is going to make it only move in the y prime direction. How am I with quantum mechanics? I don't like quantum. I can try. I have other friends that really like quantum, though. Maybe that's the only bar? Wait, what? You're assuming another bar on the top left? What do you mean by bar? Sorry. You mean a ball? What are you talking about? Bars. Sorry, let me look at... Oh, I see what you're saying. Maybe the whole thing is tilted up? No. Only one corner is tilted up? Oh, wow. Oh, that's whack. Wait, so these are not both on the ground then? Shouldn't this be up in the air a little bit then? Right? Right? This should not be on the ground. I assume they're both on the ground as well. Okay. Oh, I see. This is on the ground, but this is not. No. I think I see what's happening. Right? Well, it actually doesn't say. Cause sorry, it says that it's launched from one corner. It doesn't say that they're both on the ground. Yeah, Hamiltonian dynamics says they're both on the ground, right? Yeah, we're not crazy, right? That'd be really weird. Like, is this like somehow like what's happening? I think they're both on the ground. Okay, so if they're both on the ground, gravity should not affect in this direction, right? Ooh, Lily says, why not use the vector equations of kinematics? I was just going to break into 2 dimensions. I don't know what the vector form of them are. I just want to say this, right? Y prime is equal to 0. Plus V naught sine theta t. And then this would be minus 1/2 g sine of 20 degrees. And then t squared? Curious if you feed this in the GBT. Yeah, so Gladiator was saying when they fed this in the GBT that GPT did assume that there was some acceleration in the x direction. Maybe replace displacement, velocity, and gravity with their vector versions. I think usually you want to separate things out though into components. I mean, this is just the same thing. All right, you know, we can send it to Gemini. You want to send it to Gemini? Gemini's sometimes smarter. I'm just curious. Why not, bro? I'm using AI to verify, dog. Yeah, okay. G sine theta. Yeah, I agree with that. And then they use the range equation. I guess that works. It's cute. So I'm curious, Gladiator, what's the correct answer? What's the correct answer according to your book? Is it either one of these? 34.3 degrees or 55.7 degrees? 34.3? Okay. Well then, yeah, okay. Well, ChatGPT didn't, or Gemini, sorry, did not assume that it was cosine theta for the gravity. You do need cosine theta for the initial velocity. This is true, right? They are doing the range equation, which is a cute thing you should like kind of have memorized. You could also calculate it this way, right? Because x prime is just gonna be like 2.5 is equal to v naught cosine theta t, right? And then from this, right, you have 0 is equal to v naught sine theta t minus 1/2 g sine 20 degrees t squared. I forget how the range equation works. I think we substitute in this value for t, right? Is that what we do? So from this, I can say that t is equal to 2.5 v naught cosine theta, right? Or 2.5 divided by, sorry, v naught cosine theta, right? And then you can substitute into here, right? So then you have 0 is equal to v naught sine theta. And then this is t. So you have this. Then it's minus g over 2 sine 20 degrees. And then it's this squared. This is ugly, though. Where does the range equation come from this? It's easier to solve for t. Oh, from here. Oh, yeah. See, that's what I thought. I was like, wait, I feel like this is the wrong way to do it.
Oh shit, not good.
Yeah, I know what you're saying. Okay. Yeah, I was trying to remember. I'm like, wait a minute. I remember there was something nice with it. Yeah. It's from this. Yeah. Okay. Divide by t. Divide by t. Divide by t. And then move over, right? So then you have 1/2 g sine 20 degrees t is equal to v naught sine theta. I remember how this works now. Okay. And then you plug it into this one for t, right? All right, so t is equal to v naught sine theta, and then sorry, there's gonna be a 2 here from this coming underneath, and then you have g sine 20 degrees, and then you take this and you plug it into this. That's okay. I remember there's some identity that pops out. So this is cool because this is 2.5, and then that's going to be equal to 2 v naught squared over g sine 20 degrees, and then it's cosine theta sine theta, right? And you're trying to solve for theta. So then I think what you recognize is that this is equal to 1/2 sine 2 theta. Yeah, because this is the identity. And we had this one earlier. I remember where this comes from. Yeah. Right. Okay, cool. So yeah, from this, you get this. Okay, let's make it different colors. Yeah, this is the same thing as this. This nonsense that's happening. Okay. So then, moving everything over. Wait, and sorry, what are we solving for again? Oh, we have v naught. V naught's 3. Okay. Cool. Okay, so you get 2.5 is equal to 2 times 3 squared over g sine 20 degrees. And then this is times 1/2 sine of 2 theta. So now all of this just algebra it out, right? So sine of 2 theta is equal to, what's that going to be? So that's 2.5 divided by 9, right? And then times 9.8. And times the sine of 20 degrees. So we get 0.93. Is that what Gemini got? Yeah, 0.9311. Nice. Cool. This is why AI is cool. It's good to like verify that I'm not crazy. Otherwise, you just be wasting a lot of time. So 0.931. And then take the inverse sine of both sides, right? And that gets you that 2 theta is equal to... $68.6. Oh, and technically, ooh, this is interesting. You have to account for, there are 2 solutions here, right? Doesn't the other one work as well? Just because of how arcsine works? Right? So you can have 68.6 here, but you could also have the one over here. Because arcsine is defined in only quadrants 1 and 4. But technically, this one could happen as well. Yeah, so there actually is another one here. So this is or, and then this is 180 minus 68.6. This is like the ambiguous case you got to be careful about. And this is 111.4. So theta equals 34.3 degrees or 55.7. Yeah. Which is that what Gemini got? Yeah, 55.7, 34.3. Okay, cool. Great. We're good. And those 2 solutions add up to 90 degrees. Yep. Because the 2 theta solutions should add up to 180. Very cool. Yeah, and the range equation, right? Yeah, there's 2 angles, right? Yeah, like 25 and 75 both give you the same range. Nice. Good question, Gladiator. Any 2 angles equal distance from 45 would give the same answer. Yeah, I agree. Which means I add up to 90. All right, let's see what we got. What's the next one on the queue? Anthony. Ooh, I did this one for you, Anthony, though, right? I'm pretty sure I did this one for you. Yeah, do not solve for theta. Right, we did this one. Okay, cool. Mark that was done. I'll just post the solution back in for him. All right, there you go. All right, 2 ones left. Let's see, Jacob. What did Jacob give us? Jacob might have given us something hard. Oh, actually, no, not too bad. Just a lot of physics. Okay. And then let me see. Well, we got 30 minutes. I'll be able to do this, and then the next one. Yeah, that's easy. Gio, you think if you took an AP Physics exam right now, you would score a 5? Yeah, probably. I don't know. Some of them are like really time consuming. I would probably make some stupid mistakes just because, again, I teach everything. So my brain isn't like 100% focused right now on AP Physics. I mean, I know a lot of AP Physics, don't get me wrong. But in a testing environment, like, it's time limited. So you have to like really like lock in and focus in on just like one subject. And I'm so used to teaching everything like chemistry, stats, calculus, physics too. So yeah, I think I could. It's not guaranteed though. I definitely don't know everything. I'm trying to know everything, but I know I will never know everything. Okay. Let's see what we got. Lies, he says. Do you do bio? I mean, yes. The question is, like, what do you do in bio? I mean, I know that the mitochondria is the powerhouse of the power center of the cell, right? Yeah, Gladiator, that double incline spring question is nonsense. It's not solvable, the one you created. If you want something that's like kind of tricky with yeah. Oh, for number okay, one second. All right, let's see. Can three vectors of different so the other wait one sec before I do this. Gladiator, if you want like more practice questions on like mechanics type stuff, just go to, and because teachers do this all the time. They don't want to create new problems. They don't want to write new shit. If you go to like AP Physics C practice FRQs, basically like the practice questions from mechanics, like just go here. You can look at the previous years. Here we go. Wait, do they only show really what? Only the last 3 years? Dude, this is wrong. Sorry, what? Okay. Whatever, but yeah. So if you go here, just go check out the other questions that they ask. They probably have one, like here's a good one with like a spring. That's kind of cool. But you want like an inclined plane in a spring? I know like I ask it, like the double inclined plane shows up a lot. Wait, there's some noise in my apartment. What the hell's going on? Oh, someone's like drilling something. I'm trying to see if they have one, which is like kind of an inclined plane question. Oh, here you go. Yeah, this is a good one, right? These are good questions. Inclined planes with springs and friction. These are types of questions you can maybe ask. Money, please. Please send $10 shipping and handling. Okay, here. Let's just do this real quick. Okay, can 3 vectors of different magnitudes and directions add to 0? Sure. Yeah, check those out. Yeah. So for instance, if this was like yeah, I don't know. Like, can 3 vectors? Yeah, we could do this. I'm going to show with a diagram. I don't actually, like, want to do it. The numbers would be kind of annoying. But, like, something like this. Oh, Jeff has the numbers. Yeah, okay. 3, 4. 3, 4, negative. Yeah. Okay, those would work. Do a Pythagorean triangle. Do a barrel roll. No. Yeah, actually, yeah, right. This would be what? This would be negative 3, 4, right? And then this would be negative 3, negative 4, and then this one would just be 3, 0. Yeah, any triangle. Oh, okay. Wait. Sorry, the vectors have to be different magnitudes and directions. Oh, that's annoying. No. Wait, these don't add to 0? Why do these? Oh, they don't add to 0. You're right. Right. Yeah. Sorry, because negative 3. Sorry, this would have to be 6. Sorry, my bad. Yeah, interesting that they, because technically this has the same magnitude as this one, right? Okay, Jeff's got it. Yeah, those work as well. Okay. 3, 0, 0, 4. Yes. Okay, cool. All right, yeah. That works as well. Sure, we can do that as well. So, yeah. If this is 3, 0, and then this is 0, 4. So adding these two together, right, would create this vector. So then you need the opposite to that vector to get to 0. Yes, Jeff's correct. You could do this. And then this would be -3, -4. Yeah. Great. Cool. That would work. That's fun. Okay. The delta symbol is used in math and science to indicate what? I don't know, like supremacy, dominance? Dominance? It equals change. Yes. So delta t. And here's the thing. This usually means like t final minus t initial. So you can say like change in time. Delta d is usually change in displacement, maybe? I don't like the delta d. It's kind of weird. I don't want to say change in distance either, right? Because distance and displacement are two different things. I think it's displacement. Change in position? Yeah, okay. That's a better way to say it. Yeah, sure. Right, change in position is displacement. No? It's not, yeah, it's not change in distance, technically. Yeah, displacement is S, yeah. Okay, add all the following vectors. Sure, this is 10. This would be 0. Right? Because they cancel each other out. No. Messi or Ronaldo? Messi, dude, he's a goat.
My man.
This would be 15. This would be -5. This would be -10. And then this, I don't know. This would be 5. Because 10 up and 5 down is 5 up. Rare L.
Huh?
I think Messi's the GOAT. Is Messi not considered the GOAT in footy? Whatever you guys call it. Soccer? He's like the Tom Brady of like quarterbacks, right? I mean, you can like hate him, but he's still the GOAT. Why do you think Ronaldo is better than Messi? You have to give me a reason. Does he have more World Cups? Does he have more what are they called? Ball d'Ors? Golden balls? Layla says Messi's the GOAT. Pineapple says, is taking calculus before advanced functions possible? So it's very interesting. You're probably from Canada, Pineapple, right? Because this like advanced functions class, I've never heard of in the US. And I think it's kind of akin to pre-calc. Yeah, I know you're in Canada. Yeah. I think anybody can take calculus. I think calculus is a great class and everyone should take it. I think it helps to know a little bit of trig before you take calculus, because a lot of the trig substitution stuff would make more sense if you understood trig. You did take... Okay, then you're probably fine. Do you think they'll rename it Canada when it becomes part of the US? Oh, dear. I don't know. Pavel says, more goals, dominated Champions League, did more for his country, and a major statistic everyone forgets about. He's never won a trophy without having the most goals and attempts on his team. So he's the best player on his team. But who's the best team player then? I feel like Messi's the better team player then. I don't know. I'm not super invested in footy these days. Okay. For north, so you can always like describe things in terms of vectors. So this would be like 0, 4. 2 west would be like -2, 0. 3 south is 0, -3. And then 2 east is 2, 0. So when you add those all up, this becomes -2 plus 2, comma, 4 minus 3, and that's equal to 0, comma 1. We are, of course, yes. I don't want to sketch and solve it. But the total distance traveled, okay, this is actually cool. So the total distance, this ends up being 4 plus 2 plus 3 plus 2. So that's, because it's the absolute value of, like, your displacement. So 6, 9, 11. The car is on the pole.
You're not that guy, pal. Trust me. You're not that guy.
Okay. And then displacement is 1. Yeah, I don't know all the leagues. I know there's like Premier League, there's like Champions League, then there's like La Liga. There's so many leagues. I want to say, I think UK soccer has like the strongest like league, right? Because everyone wants to play for like Premier or Champions or whatever. He's from Man U, right? Okay. And then this one would be 0, 4, 0, minus 7. Ooh. 0, minus 2.5. Minus 2.5. And then 0, 5. Interesting. So 9 minus 9.5. Yeah, you guys are right. I think it's negative 0.5. Yeah. Okay. A child walks 3.5 meters in the positive direction, turns around and walks 7 meters in the opposite direction. If their final displacement is 0, what was the walk's displacement? Oh, the last walk's displacement. Oh, okay. So if they go up 3.5, but then they like come down 7, then the final one had to be also up 3.5. All good. Great job, guys.
Well done.
That was Jacob.
Well done.
Good question, Jacob. All right, we're going to put Jacob's screenshot in the Discord. See what we got next on the list. Last one, SB1214. Oh dear, SB. What is this engineering stuff? Oh, Christ. Indicate if it is stable or unstable. If it's unstable, indicate the reason. Sorry, gang. Is this you, Sarah? Sarah, is this your question? The structure is stable. Indicate if DSI. What does DSI mean? This is statics, right? You're taking statics or something. Hinge. What does a hinge mean? Okay. Well, I guess, okay, these can like kind of like bend from each other. Is that kind of like what happens? Like these can like, this is due by midnight. I don't know, man. It's like a door hinge, maybe. Oh, okay. Is this also a hinge? I'm looking at this. I feel like, what are these different shapes? You know? Like, what is this? Is this thing, like, allowed to move in, like, these directions? Oh, that's a pin. Oh. Oh, those are rollers. Oh, man. Dude, what the shit is this?
Surprise, motherfucker.
Has to do with reaction forces. Okay. I can agree with that. Yeah, I mean, if something is stable, I'm guessing that the sum of all the reaction forces has to go to 0, right? Because otherwise you would have angular acceleration. So sorry, you need all the sum of the forces to be 0. You need all the sum of the moments to be 0, right? Do you have an engineering degree? I don't. This is actually probably one of these questions I can't do. I will attempt to use my PhD in physics knowledge to try to solve this, though. There's an equation for DSI. Ooh, what the fuck is DSI? Okay. Let's try to learn with AI. When in doubt, ChatGPT or Gemini it out. Yeah, bro, what is this? I know. It's okay. Sarah's asking some good questions today. I'm just gonna try to learn from the AI and see if it makes sense. You sure? You sure can't do it? Let's see. I'm just curious. I want to see what it says. I used to watch DSI. Dude, DSI Miami? Yeah! Dude, I love those memes. Okay, degree of what? Oh no. Degree of statical indeterminacy. Which is better, Gemini or GPT? I'm a long-time GPT user, but I think Gemini's been doing better recently, at least with math stuff. Okay, let's see. Let's identify the unknowns, reactions, and the available equilibrium. So the fixed support on the left provides 3 reactions: a horizontal force, a vertical force, and a moment. So I had it just do it for this one, by the way. I agree, Black Pill. Yeah, Gemini has been mogging ChatGPT. Yeah, I agree. This is fixed, no? Right? Fixed to a wall. And then what are they talking about? Let's identify. There's a horizontal force, a vertical force, and a moment. Roller support in the middle. There is a roller support here. So roller support can only provide forces in the up-down direction, right? I don't think a roller force can provide up-down. Right, yeah, okay, 1 reaction. And no moments. Well, okay, so this is always, I get confused, like moment, like, so for me, moment means torque, which means reference to like some rotation angle. Bro, stop talking. I like his talk. It's okay. Let him talk. I need to learn the new lingo from you guys anyways. Although I feel like mogging's been out for a while. I don't know why that one's making a resurgence. Yeah, I get that it's force times distance for sure, Sarah. I understand that. But the distance is measured from where then? Right? Because, you know, let's say for instance, let's make a really like easy case here, right? Let's just say you have like something like this, right? Then you have a couple forces, right? So here you would have definitely like an upwards force, right? And then like a rightwards force. Let's say this is like a pin, like this is connected, right? And then you definitely have like a force of gravity from the weight of the thing, right? So when I think about moments, right? If I consider, and then, okay, if this thing were to be static, I guess you would need another force somewhere, right? So let's say you had, like, for instance, a wall here, and then you had, I don't know, yeah, like a piece of, well, actually, make this different color. Yeah. Let's say you had, like, a rope. Oh. And this was providing, like, a force in this direction. I guess what you would say then, right, is that this force provides a moment because it has some distance from a rotation point. And then you would say that this force provides a moment, right? Because again, it has like some distance from a rotation point, but that these forces do not provide a moment because the distance that these forces act from the rotation point is 0. But in physics, I could also define my rotation point to be somewhere else. I could pretend that this is my rotation point. And now suddenly this exerts a torque. These forces exert torques, but this one does not. I guess this is the engineering translation I get confused with when they start calling things moments. Because I agree that, like, torque is equal to R cross F, which is basically the same thing as, like, R perp times F or R times F perp. But then this R is always subjective to, like, where you're measuring torque from. So if you're measuring it from here versus measuring it from here, those get you two different values of torque. Yeah, but if you make a cut, you get a shear and moments. That's what I think it means. Yeah, and this is the engineering part I start getting confused. Yes, because you guys start talking about torsion. Yes, and like, okay. There's an internal moment. Oh, man. One of these days, I'm just going to take statics. I'm just going to enroll at like a local community college and just fucking take statics. It's so, dude, again, I have a PhD in physics, like, but I still can't understand what moments are in engineering. It's because of the jargon. But okay, let's just see what chat was saying. So it said, the fixed support on the left had 3 reactions. Said a horizontal force. Sorry, let me move this over. Horizontal force, right? So this had a horizontal force, a vertical force, and then it said it also had a moment. Okay, cool. And then this also has a moment. Maybe we'll do this. We'll call this like moment. Maybe is that cool? No, I'm getting, dude. If anything, Black Pill, dude, I'm getting mogged. I'm getting mogged by a 19-year-old engineering question. Yeah, I'm the one getting mogged. I'm not doing the mogging. Yeah. Okay, so the roller support here, I agree. Because it's not, like, connected to anything, it can't, I guess, really rotate it? Is that kind of what we think about there, Sarah? So I agree that this has just an upwards force. Yeah, my statics prop was a physicist. Yeah. I just never learned the statics terminology is the problem. I just never learned it because I didn't need to learn it. We just learned torque. Okay, the hinge. Okay, the hinge at the bottom right provides 2 reactions. So they're saying this right here is going to provide a horizontal and a vertical. But why is there no moment here? See, there's no moment here, apparently. And then yeah, it has X and Y, but oh, does it not have moments because it can rotate? Is that what we say, Sarah? It's free to rotate if it's a pin. Yeah, because it can rotate. Okay, cool. No, you're good. See, I'm learning alongside you. Thank you.
Good job.
You're teaching me. Okay, and then the hinge, I guess, also rotates so it doesn't have a moment. So this has up and down forces. Okay. Or sorry, wait. The internal hinge provides one additional equation of m equals 0. Oh, okay. Wait, no. Sorry. So here we would say that sum of moments. So I sorry, the internal hinge, sorry. Okay, sorry, I had to cough that out. The internal hinge doesn't provide any forces, but the condition for this to be stable, I guess, for it to be static, is for it not to be bending. So the sum of the moments there have to be 0 at the hinge, right? So basically, like, this and this can't, like, rotate with each other. Okay. Okay, so total reactions is 3 plus 1 plus 2 equals 6. So total equations is 3n plus EC. I don't know what EC is. I don't know where this comes from. For a single structure, we will use 3 equilibrium conditions. The internal hinge adds 1 condition equation. So the total equations are 4. Okay, wait. Sorry. Can you tell me about enzymes? Enzymes lower the activation energies of things. That's why they make things react faster. It's like pouring gasoline on a fire. That's enzymes. Okay. In order to be stable, a structure must meet 2 criteria. R, which is the number of reactions. Which, okay, we found here, right? Yeah. 1, 2, 3, 4. Wait, I got 5. Where do we get 3 plus 1 plus 2? Oh, yeah. Wait. Okay. Moments count as reactions, Sarah. So this is 3 plus 1 plus 2. That's 6. And 6 is greater than 3 plus EC. And I don't know what N is. Is N like the number of things? I guess you have 3 things, right? 1, 2, 3. I guess you don't count the hinge, maybe. Okay. The reactions must not be concurrent, all meeting at one point, or all parallel. The fixed support prevents rotation and translation. I agree. So this is fixed. You haven't seen... Yeah, okay. The supports are arranged such that there's no mechanism. The structure cannot move without deforming. I agree. Right? In order for this to, like, rotate, this would... We assume this is fixed, right? This would have to, like, bend and do some weird shit. And then... I assume this is also fixed, right? So stable. And then DSI is R minus 3 plus EC. So R is the number of reactions, which is the total number of things and... So forces and moments, basically. And then EC... The fuck is EC? God damn it, Black Pill, dude. Given that Sarah's professor is a physics person, and me as a physics person, I don't know many physics people that are Chads. So I don't think it would have helped. Black Pill. I don't think it would have. Okay. So this is DSI is equal to 2. Yeah, so here's what I want to know. I want to know where the... What's the EC? Oh, she. Okay. Maybe she's a what's the female equivalent of a Chad? Like a Becky? What do they call it? Okay. EC stands for equations of conditions, which are constraints. These are extra equilibrium conditions by the feature. Okay. I do think Gemini is better than ChatGPT. This is cool. I'm learning about this. The hinge connecting 2 members provides n-1 equations of motion, where n is the number of members meeting at that hinge. Okay. So because this hinge has 2 things meeting at it, it provides 1 extra condition. And since the hinge connects 2 members... Good. Okay. Because a hinge cannot resist rotation, it breaks the continuity of the bending moment. This gives you 1 specific math guarantee. The sum of the moments at the exact point must be 0. Right. Right, because the hinge is free to rotate. Okay, cool. Here we go. Internal roller link, a slider. Oh, that's cool with shear force. I think I'm learning a lot here, Sarah. Okay. Do you feel like this would have helped you, Sarah? I feel like I understand this. Does this help you though? Like, does this answer seems pretty reasonable, no? And this is like the free version of Gemini. I think try. What you want to do is you don't want to dump the whole thing. You want to give it just like a single image, and then when it goes through doing things, you want to verify that makes sense. If it starts saying things are there that aren't there, that's when you want to be like, wait a minute. That doesn't sound right. This, to me, everything it told me so far seems pretty right. And I had no clue how to calculate this from the start. But I feel like I understand it now. So I think for this, we would say this is stable. And then I would say that DSI equals 2. Highest tier is True Adam, True Eve, followed by... Dude, this is degenerate. God damn it, dude. I get it. It's lore and whatnot, but what? Chad Light? Stacy Light? Stop. Okay. Oh, this is cool. So this hinge, because it has 3 things, right? This would be EC is equal to 2, right? Uh-huh. This would be EC equals 1. EC equals 1. This would be EC equals 2. Yeah? And then, I don't know, I feel like this thing's also like EC equals 2, right? But then, I don't think any of these things provide moments, right? So I think you just get... Let's just say, let me like, just for like... For doing shit sake. Can I see the equation again? Yeah. You know what I'll do? Can I share this with you? Here, let me post your question in our Discord, and I'm just gonna, because I have to go here pretty quickly. I'm gonna post the link to this in the Discord so that you can see it. Here, I'm gonna copy the response. Actually, here, can I just share it? Fuck, where's like just export? God damn it. Can I not make this easy? Share a conversation. There we go. Okay, cool. Here, I'm gonna create a link for it. So inside in our Discord here. No, not that guy. So the same website you went to go like submit things. I forget if you're in our Discord or not. But if you're just watching, anyone else you want to join. So in here, I'll post the link to what the Gemini conversation was. And then also, I'm going to post what I think the ECs are for this. Yeah. Cool question. I actually learned a lot. I learned a lot alongside you, Sarah, here with this. I think eventually one of these days I'll learn this. But to me, yeah, it's interesting. All engineering seems to be is memorizing... like wacky equations. Like I have no fucking clue where this comes from. Like I don't know that the static criterion is R is greater than or equal to 3 plus EC. Like where'd that come from? That's what annoys me about engineering. Anyways, okay, I gotta go. So let's close out the stream. All right, thank you everyone for coming to Actual Education Office Hours. Appreciate everyone. Appreciate all the feedback, all the comments, chat. Y'all been great. Sarah, you've been great teaching me engineering. This is going to be you in engineering next year? Yeah, it might be. So, yeah, listen up. Learn alongside us so you don't get burned later. If you just found us today from any of the whatever websites, TikTok, YouTube, please go to the website, actualofficehours.com. That's where people are submitting their questions. Join our Discord. That's the best way to stay up to date with all the fun stuff we do. We give out prizes. We play video games. We're a really fun nonprofit. Y'all should come check us out. And also watch us live on Twitch, because Twitch is the best platform. It's horizontal. Things look really nice. And then also check out our streaming schedule, because I'm not the only person that does this. And there are a lot of other really awesome people that are streaming math and science stuff. For instance, yeah, Math Pawn's going to be doing probability tomorrow, 1 to 2 o'clock. Zach's going to be doing some cool math through task stuff. We will be back streaming at 6 o'clock Pacific, 7 p.m. Mountain, 8 p.m. Central, 9 p.m. Eastern. So come on by. Check out all the fun stuff. Yeah. All right. We're going to go raid somebody on Twitch. So this is what we do to like say hello to somebody and support other streamers that do similar stuff. Let's see. Who's online right now? Curly's playing video games. Moo Hoodles. Artemis 2 recap. I haven't seen Moo in a second. Let's go say hi to Moo. I like Moo. She's great. She's an astronomy space physics scientist person, and she's dope. Cool. All right. Enjoy the start of the week. I hope you guys have an awesome Monday. We'll see you tomorrow. Peace.
It was the same bus that they use, I think, to go to the Saturn V, like Apollo place in the visitor center. But I also didn't get to do that. But they were the same buses, so yeah, it was quiet this time. Hey, Actual Education, thanks for raiding in. How was your stream? I hope you had a good one. Welcome in, raiders. Hello. Oh, and thanks for all the kind words in chat and everything, y'all. I appreciate it. Hopefully I didn't miss anything. If y'all aren't following Actual Education, they're a 501c3 nonprofit that does a whole bunch of cool education and tutoring stuff. And they do a whole bunch of things on Twitch here. I got to meet them at TwitchCon, which was super awesome. And yeah, it was rad. I hope you've been doing well. I hope your streams are going great. Be sure to go follow